Hello and welcome to this video on net present value, NPV, which is a form of investment appraisal. By the end of this video, you should be able to use net present value to appraise investments and compare the usefulness of NPV to ARR and payback. So far we've looked at two forms of investment appraisal, payback and ARR, average rate of return. Payback focuses mainly on the timings of cash flows, and average rate of return focuses mainly on the profitability, which can give rise to some problems. For example, if we compare the net cash flows of these two projects and we consider payback as our form of investment appraisal, which project would the payback approach suggest we should go for, project A or project B? Well, which of these two projects pays back quicker? Project B, we'd have to wait more than 1 year to generate enough net cash flow to pay back the initial investment, whereas project A would pay back within 1 year or at the end of 1 year. So using the payback approach, we would go for project A. Now, if you look at these new net cash flow profiles, which project realistically would you prefer to invest in? Well, project B produces 120,000 in terms of return, whereas project A produces half as much, only 60,000. So payback takes into account the timings, but maybe isn't so good at taking into account the whole return. Let's contrast that with another example, and here we're going to use average rate of return. What would be the average rates of returns for these two projects? Well, the initial investments are the same, and both returns are 120,000 in total. So they would give the same average rate of return. But again, if you look at the profiles of the cash flows and the returns, which of these two projects would you prefer? Well, most people would prefer project A, I would imagine, because we prefer to get our return earlier rather than later. So again here, ARR has a problem in that it doesn't take into account the timings. So what we need is an investment appraisal technique that considers both the magnitude of the returns and also the timing of the returns, and net present value does that. Okay, here's a deal for you. I will give you either £1,000 right now or £1,200 in 3 years' time. And the big question is, which deal should you take? Well, the question you might be asking yourself is, if I take £1,000 now and I stick it in the bank, what would it be worth in 3 years' time? So that I can make a fair comparison between the two deals. Let's imagine the interest rate in the bank at the moment was 10%. In 3 years' time, your £1,000 would be worth £1,331. So should you have taken this deal on the right? No way. So the future value of £1,000 in 3 years' time is £1,331. And if we flip that statement on its head, the value of £1,331 right now is £1,000. The concept of present value is an important one we need to understand to be able to do net present value calculations. Present value is what money in the future is worth now. So to look at our example again of the £1,000 deal, I gave you £1,000 in year 0, and you would put that into the bank at a 10% rate of interest. After 1 year, your £1,000, add on 10%, £100 would be worth 1,100. Add another 10% of that amount to be 1,210. Add on another 10%, £1,331. So the future value of £1,000 after 3 years is £1,331, and the present value of the future £1,331 is £1,000. Now, what we're interested in doing with future cash flows from our investment projects is seeing, right, well, if that's what's occurring in the future, what is it worth right now? So if I'm going to convert 1,331 to 1,000, what would I need to multiply it by? Well, if I look at this column over here, it tells me the number by which I need to multiply my future value to get my present value. And we call that a discount factor. A discount factor will get future values of money back to what they are worth right now by multiplying them. And you can see that the further into the future we get, the smaller the discount factor is that we apply. So these all apply here at a 10% interest rate, but if it was a different percent interest rate, these would be slightly different figures depending on how much interest we would have earned. Now with these discount factors, we can use them to take any future value of money and bring it back to what it'd be worth in year zero. So let's have a look at a few examples. Right, £80 in year zero is worth £80 in year zero. £120 in year one, assuming we could get 10% rate of interest in the bank, is worth £109 in year zero. So £109 9 pence, add on 10%, would get you to 120. £140 in year two is worth £115 in year zero. The present value of year two would be £115.70. The present value of £60 given to you in year three would be £45.08 today. So we use this concept of discount factors to take future cash flows and bring them back into what they're worth today, assuming a certain rate of interest at the bank. As I said, discount factors at 10% would be these ones, but as we go get different rates of interest perhaps in the bank, then we might consider using different discount factors to do our calculations. So this table here shows us the discount factors for different rates of interest, and you'll normally be given these. You wouldn't need to calculate these. So if that's left you all feeling a bit confused, don't worry, maybe watch it again or ask questions. But the good thing is, even if that has left you feeling a bit confused, you can still perform net present value calculations by following some simple steps. So let's bring it back to business now and have a look at some projects. A business is considering two alternative projects, Project A and Project B. Both projects cost £250,000 and they both have a total net return of £100,000. Here's Project A, so you can see 250,000 is the initial outlay in year zero, and then these are the returns coming back in. So in year one, 50,000, 200,000, year three, 200,000. So that's £350,000 coming in, 250,000 initial cost, so total net return 100,000. Here is for Project B. Again, you can see the initial cost going out, negative number, and then the returns coming in years 1, years 2, and years 3. So the question might be, which project should the business invest in? Again, ARR is going to give us the same answer here, but the timing of the cash flows is important, and that's where net present value comes in. So how do we calculate net present value? Well, 4 simple steps. Step 1, we need to list out the net cash flow for the life of the project. Step 2, we need to select the discount factors and add them to our table next to our net cash flows, depending on what interest rate we want to use. Step 3, we multiply the net cash flows by the discount factors to get them into the present value. And then we add up all the present values to get the net amount. So let's look at Project A first of all, and we're going to assume that a 10% rate of interest is the return we could get on our money. So here is our table. Again, we've got years, 3-year life of the project. In year 0, we have net cash flow of minus £250,000. That's the cost. And then you can see the returns coming in, 50,000, 100,000, 200,000. Now, what we need to do to take into account the timings of these cash flows is bring them back to their present values. So what are they worth in year 0, assuming that we could get 10% interest at the bank? Well, here are our discount factors at a 10% rate of interest. And if we multiply across the cash flows by the discount factors, we get the present values. So £250,000 negative in year 0, the present value is negative 250,000. 50,000 return after a year is worth 45,000 in year 0. 100,000 after 2 years is worth 83,000 in year 0. 200,000 after 3 years is worth 150,000. So these are all the present values of our project. And to find out what the overall present value, the net present value is, we simply add them all together. And so the net present value of this project will be £28,500. That's how much it's worth right now in year 0. Let's now look at Project B. Again, a quick reminder, these are the steps that we need to follow. We use Project B, assuming a 10% rate of interest. Here are our years and net cash flows, and what I would like you to do is pause the video and see if you could work out what the net present value is for project B. Well, let's see how you got on. Again, we need to put in the discount factors at a 10% rate of interest in the bank, and then we convert our future values to present values by multiplying across the net cash flow with the discount factor. Once we have all our present values, to get the net present value, we simply add them all together. And here, did you get this answer? The net present value of project B is £52,500. So we have our two projects, project A, a net present value of £28,500, and project B, a net present value of £52,500. So remember, these would both have the same average rate of return, but we can see because project B, we get our money back sooner, this project actually comes out preferable because it takes into account we'd rather have money sooner and then be able to reinvest that than be waiting a long time for our return. So more discount is applied to this than it is applied to this. So here, if you were to ask me on a net present value basis, I'd be opting for project B. So firms can use net present value, this investment appraisal technique, in two ways. Number one, they can choose between projects by selecting the project with the highest net present value. Or two, they can choose to select all projects with a positive net present value or with an NPV that exceeds their cutoff criteria. So what are the advantages and disadvantages of this approach? Well, there's some advantages. It takes account what we know as the time value of money. The fact that having money back sooner and then being able to reinvest it is more valuable than waiting a long time to receive your return. So it places an emphasis on earlier cash flows. Number two, it looks at all the cash flows involved in the project rather than payback, which would just look at when you get the money that comes back until it's paid off the initial investment. The use of discounting reduces the impact of long-term cash flows in our calculation. And by their very nature, these long-term cash flows are maybe more uncertain or perhaps less likely to be accurate. So less weighting is applied to long-term predictions. The last advantage has a very clear decision-making mechanism. We reject projects with a negative NPV. They're not going to generate positive present value, whereas projects with a positive net present value we can accept. Some disadvantages perhaps, it is more complicated. Some users may find it more difficult to understand within the finance department. Again, it's difficult to select the appropriate discount rate. So would they be getting 10% return on their money otherwise? Would it be 12%, 8%? What is the appropriate rate that they might alternatively get? And the NPV calculation is very sensitive to the initial investment cost. So that has quite a big effect because it is a present value. Again, we need to consider some broader questions about our investments. Will they help meet the corporate objectives of our business? Will the business be able to finance the initial outlay? How certain or risky are the future projections that are being made? What is going to be the impact on the workforce? Are there any ethical or environmental considerations we should take into account? So when a business is setting the investment criteria for one of its projects, what might it do? Payback, NPV and ARR can create conflicting results, as we've seen. So how would you decide on which method or which investment to pick? So possible criteria might suggest only accepting investment proposals which meet at least two measures. So for example, they might say we will only accept investments with a payback within 4 years and an NPV of at least 25% of the initial investment, or an ARR of at least 20%. So firms might use combinations of these techniques and tools to have a set of criteria for any potential investments. Some key issues to consider when we're evaluating investment appraisal. The first one is the timing of the project, or the length of the project. The longer the project, the greater the risk that estimated revenues, costs, and cash flows might prove unrealistic. Second thing to consider is the source of the data that's being used. Are the estimated project profits and cash flows based on detailed research? Are they based on gut feel, or little of both? and who produced it. Is it an experienced member of staff or is it third-party data? Again, we can question the source of the data and how accurate that might be. Again, another issue for consideration is the size of the investment. An investment that takes up a lot of the firm's available funds is by definition more risky than a smaller investment that uses less of the available funds to a business. We also need to consider the market and economic environment. So the stages through which the economy are going, if it's moving into slump and recession, this makes anticipating future cash flows more tricky and potentially likely to be less accurate. So changing market and economic conditions can make forecasts inaccurate and lead to poor investment decisions. The last thing to consider is the experience of the management team. A project in a market in which the management team has a strong experience is a lower risk proposition than one in which the business is taking a step into the unknown. So that's worth considering when we're evaluating investment appraisal. So those issues there for you to write down: the length of the project, source of the data, the size of the investment, what's going on in the economic and market environment, and lastly, experience of a management team. So you might want to pause this, make sure you've got it covered, and then move on. So in this video, we have set out to be able to use NPV to appraise investments. Again, we need to know the method even if we don't fully understand the rationale behind it. And we also should be able to compare the usefulness of NPV to ARR and payback, be able to evaluate these methods, and be able to offer some counterbalances to investment appraisal techniques. That's it. Thank you very much.